I am Samantha MacBride of Baruch College. I'm here with my colleagues, and we're going to talk about a new data set that now makes it available, possible for you to know where your personal trash is ending up if you live in New York City. Now, what is this one?
Maybe here. Click it towards this here.
Oh, okay. Next slide. So I'm gonna just introduce you briefly to the data sets and the stories that they can tell, and then talk a little bit about the struggles for obtaining this data set and say thank you to the open data team that helped so much make it possible. Next slide, please. So a waste trajectory is a voyage. It's a trip. And in the case of what we're talking about here, it's a trip from the moment you throw something away to a destination for disposal, either a landfill or an incinerator, aka waste to energy facility, and what I will call here a combustor. And that journey can take many different routes. Those routes change over time, but none of them make waste go away. Next slide. So the progress in New York City is a person throws something out. It goes into the curbside bin that is put in front of the building. It's collected 2 or 3 times a week. It's taken to a sanitation garage, and the community district you live in has a sanitation garage dedicated just to your community district. In most cases, then, the truck is going to go to a transfer station to discharge or dump its load. In a few cases, it goes directly to a combustor in either Newark or in Long Island. But in most cases, it's going to go to a transfer station, marine or land-based, and then it's going to continue its journey by going by barge to train or somewhat to long-haul trucking, although that is going away. It's not really practiced that much. Next slide. There are as many waste trajectories as there are people in New York City. Waste trajectories are something that are heavily influenced and structured by municipal contracting and municipal operations. And when those contractual situations change, the waste trajectories may change. So it's important never to accept an explanation of where does my garbage go or where does my recycling go as if it's a static, permanent situation. These things are going to be changing, and they're going to be changing frequently based on contracting and the private sector decisions of the firms that are contracted with. There's a little bit also of exceptions that happen with sanitation operations when things don't go the way they should, but those are really minor. The trajectories that we will see in this story are largely going to be following big infrastructure and contracting. Next slide. They will not be following the flow of waste in full. However, these data sets are not going to look at the export of ash to ash fills or the export of sifted scrap metal to metal recycling, nor are we going to be looking at the process wastes from both combustion and landfilling that have to go to hazardous waste disposal facilities or the treatment of landfill leachate. Next slide. And overall, what we're talking about today is the flow of trash, not the flow of recycling or composting. It is the vast, vast majority of the material, the municipal material that is moved by Department of Sanitation is still trash. Next slide. The data sets, my colleagues will tell you about them in detail. I'm not going to go into close detail now. But our basic unit of analysis is the community district, which is the sanitation district. Next slide. And we're going to be following one data set. Will take you from collection to the garage. to the transfer station. And the second data set is taking you from the transfer station to various destinations outside of New York City. Next slide. The transfer stations and landfills or combustors outside of New York City, you should be aware that sanitation calls transfer stations facilities in the data sets that we're using, and calls landfills and combustor disposal sites. This can be confusing. They call transfer stations vendors in other data sets. The data sets also include a lot of additional information. Next slide. So here, what we've done, as I mentioned before, is we've joined these two data sets. The new data, this data set has been up on open data for a while now. This one is new as of July 2024. Next slide. And with these data sets, what can we do? Well, number one, we see that the data on tonnage that comes from DSNY collection data generally matches up with the data on what's flowing through the transfer stations to the landfill. So that's a good check. But much more important is this data will tell you what goes where. How much is going to combustors, how much is going to landfills, and exactly where they are, and what kind of routes are being traversed, and what kind of transportation mode, and how much it all costs. That is all in this new data set. And one of the things that it does show over time is progress on the 2006 Solid Waste Management Plan, that plan for a transition to marine transfer stations and borough-based equity. This was a long environmental justice fight, and it was a very long implementation process. But if you look at where the transfer stations are in these data sets over time, you see the refuse being consolidated over time into these marine stations and some land-based stations. And you see a shift to largely rail-based transport outside the city. Next slide. So this data set goes back to the 2006 Solid Waste Management Plan, and it was first reported to the public, as far as I can tell, in the 2008 Solid Waste Management Plan update. This was a sort of a proto version of the data set, next slide, that has been kept annually, by fiscal year, or even quarterly, right? So by calendar year, by fiscal year, by quarter, in the same format in a set of Excel files within the Bureau of Solid Waste Management, which manages the contracts for exported sanitation since FY 2007. How do I know this? I used to work at Department of Sanitation, and I had to consult these. I was not involved in keeping them. I was working in the recycling area. But every year I had to consult them for reporting to the state DEC, and that's the only reason I knew about them. But I also knew, as soon as I saw them, that this is one of the most important stories that needs to get out, right? Where our garbage is going and how much of it is going. Next slide, please. So I'm not going to take you through every step here. However, this PowerPoint will be up, and it takes you through the chronology of me. As soon as I retired from city service, I waited to do this, requesting that data set to go up on open data. Now, the first response was, we don't have the data in any kind of format that, we would need to do a special analysis of what you're asking for. So no, we're not going to put it on open data. I then pointed out, you're possibly a new administration. Maybe you don't know about the the Bureau of Solid Waste Management. Maybe you don't know about these files. Let me tell you where they are and tell you that they actually do exist. And furthermore, I had foiled them simultaneously so that I could show it to them, right? And then they're like, oh. And I will say that open data intervened on my behalf in a lot of this, right? So they say no, Then they say, oh, but they're like, sorry, we'll do it when we can get to it. We're just very busy, right? And so I asked for a timeline. They said they would not give a timeline. Then I go back to open data and I say, I want to do whatever procedures you have in this case. And then they relented. They said, okay, give us a year. This was machine readable data. It was in data sets. And believe me, it would not take a year to prep it. Okay, next slide. So I'm now going to turn it over to my colleagues, but the uses of this data are very important. They're very important for environmental justice and for setting standards of openness, transparency, and accountability that are desperately needed in this city for it to run well, better than it is now. I echo the comments of the head of BetaNYC this morning. And we need to rebuild trust. As my colleague Lily Pullins said, in the area of waste management, what we need now is trust and clarity.
Looks like this. Okay, hello. So I'll pick up where Samantha left off. My name's Matthew Eshed, and the title of my section is Revealing Away: Why It's Important for Waste Data to be Public, How We Did It, and What's Next. Just a little bit about me. I grew up here in the city, public school, did my undergrad in mechanical engineering, decided that the environment really needed help, so I went back to school for environmental management. And so I'm coming from a tech, hacking, open source. I was at the big 3D printer company back in the day here in Brooklyn, and now it's all about ecology, pollution, biodiversity, planetary boundaries, adaptation, and systems change. So I guess in this presentation, I'm going to be talking about the actual work that was done and the maps that were made showing this data that we just got access to, but it's also kind of a meta level about what a team looks like, and that this is a team, that there were these people who came together to get this out there, and now it's out there, and here we are today looking forward. What can we do with what we've done? So, wow, that's very sensitive. So the Stockholm Resilience Institute publishes this planetary boundaries framework, which very much informs my work, and this kind of says it all right here in terms of we've exceeded the safe operating space in several domains, and so we need to do something. We can call it an emergency if we can take it being an emergency. I decided to go to grad school during COVID out in the West to kind of get really a front row seat on what's going on with the waters of the West. In the East, I think our issues with water perhaps have to do with too much or it's too polluted. In the West, it's like, where is it? Why isn't it where we want it to be? What's up with the water rights? Things like that. I ended up... So these are a map of forever chemical spreads that I did during grad school. And this is where I connected with Samantha, where she had seen me posting about some of this work that I did. I know it's hard to see. The details aren't super important, but actually these are 50 military bases that came from a proposed bill from Senator Gillibrand called the Filthy 50, where she was proposing that there be special attention paid to certain 50 military bases that have released significant amounts of forever chemicals through their firefighting foam. Thank you. And so I just wanted to see what's going on. This is a massive situation. So I started to use GIS to get a sense of what's going on, what might we do about it. And so that then led to me connecting to Samantha in July of 2023, which you see the context from her part of the presentation. And she said, I want to make a map like this one. This is the one that she sent me and said, this is what I want it to look like. But I guess the material is going to flow the opposite way of where the waste goes.
Yeah.
So
Green markets.
Green markets was the source. Yeah. So this was the original inspiration. The data, she gave me the data, so the original data that she got from the Freedom of Information request looked basically like this. Again, I know it's very small. It's not necessarily intended for us to be able to see the numbers, but this is basically the amazing wealth of information that I received with all this interest and passion in doing something, making maps, supporting communications, supporting adaptation. This was the data that I was given. Oh, this button's really sensitive. Okay, there we go. And long story short, it's now on open data. Amazing. It's so cool. Yeah, right. Like it wasn't there before and now it's there. And we could say that it was a direct result of Samantha's work. That would be correct to say. And also it's a result of our collaborative work that we were both looking at this. We were both meeting and she was like, I don't know if it's ever gonna go public. We have to go to the media and we have to do all these things. And I was like, okay, Samantha, we can do any of that. We got this. And then she's like, oh, it's up. Okay, great. So very, very exciting. And so it kind of looks like this. You can go access these. This is just a screenshot from one of the disposal sites used by facilities by year data set. And this is what the map looks like when you just get it from the open data platform. So, okay, you can see some stuff, you know, kind of how to navigate it. And so, yeah, sorry. There we go. So this is the sort of next iteration of that original data set that I did a little bit of working with to make it feel a little bit more useful. And then it evolved into, and then from that, I was able to get some more context. Just again, like these systems are so big, what's even going on? I don't even know how do I even think about this? So we had the data from 2018 through 2021, and I could see things like the total number of contracts. And I think this is some of the information that perhaps the city was like, well, this isn't really ready to just put out there because it comes from their contracts department or division. And so I could kind of filter by, well, how many of those contracts reported collecting over 0 tons per year? And then how many of them were over 10 tons per year, with 10 sort of being a threshold, or if it's over 10, then it's like, you know, actually gets to be a significant number. And I got some fun numbers like the total vehicle miles traveled, and then convert that to how many times around the earth that was traveled. And so something like 1,700 times around the earth that was traveled. I believe this is round trip, if I'm not mistaken. So there and back, but it's a lot of times around the earth. I was able to come up with some numbers like the total amount of waste recorded going to landfill per year is about 3.3 million tons. So, whoa, there we go. We get a number. Okay, now we have a number for the data that's recorded within the system. And finally, my data set that I still use now and in collaborating with the others, who you'll see they're part of the presentation next, we actually reference this document quite a bit, that I can just filter my columns based on what I'm looking for. I'm not really a software person, but I know enough about ontology and systems development to be able to make something that can be machine readable, and somebody who knows the Python and knows the other coding languages can work with and can make much more beautiful dashboards than I can. But my job here is to kind of add the energy, add the intention and the creativity and some strategy for then creating these maps. Now I'm definitely not the best GIS person in the room. I'm sure there are other people who are better than me. I'm going to go through these kind of quickly, but then I'm going to stop on the 2021. So I made 8 maps, 4 for the whole waste shed, and then 4 for just the transfer stations. So some changes between 2018, between the 4 years. And I'll kind of stop and we'll go through it in a second. So these are what they look like. These are sort of this cultural influential communication tool, which is what maps are, to give everybody who looks at it really a sense of what's going on just in a glance. So it gets kind of crazy. Like, again, I'm sure there are better ways. I kind of wanted to make this look like a subway map. But it's kind of crazy, especially when you're looking at the transfer stations, because there are a lot of transfer stations and they're going in a lot of directions, including the barge, the marine transfer stations, North Shore Marine Transfer Station, 91st Street, which wasn't used in 2018, 91st Street, Hamilton, which I guess wasn't used, nor is it. Here we go. Sorry. Of course, we all know that one. And then there's also Southwest Marine Transfer Station, all sending their material by barge. So having done this work, I then, when I would go to the East River, I can now see the barges. I'm like, oh, there's a barge. That's what it looks like. The containers on the trucks, I went back and I saw some information you had given me that was referencing that those carry 80 tons. Each container holds 80 tons of trash, for lack of a better term. Something else that I put on this map, again, kind of a question about how to show data, how to communicate data, was the tons per day going through the different transfer stations, sorting by the highest to the, not to the lowest, but I had to cut it off at some point. So this one, we can look at things like Harlem River Yard, 2,000 tons per day. So of course there's an intersection here with environmental justice, and I'll touch on that in a few slides. Hamilton Marine Transfer Station, about 1,500 tons per day. Here's Covanta, Essex, which is the one in Newark, where it's serving as both a transfer station and a destination waste to energy facility. It's getting about 1,300 tons per day in 2021. About a third of the landfill is going to the waste to energy facilities, at least among these years with this data. So that's interesting, just to add to our kind of all of our collective awareness of what is even going on. Covanta Hempstead, you can see here in Long Island. And then, oh, there we go. Okay. So this is the one that I was going to kind of pause on. So where I put the little flames is a waste to energy. Again, there's probably a better way to make this look. So I encourage any graphic designers or cartographers to make this even better than I did, but I certainly did my best to try to give some good context for where population centers are. That's what those little black dots are. That's population, and 3 minutes. Okay. And so the dotted lines are rail and the solid line is truck. And so we can see it's going as far south as Lee County, South Carolina, and all the way up to Niagara, High Acres, and Seneca Meadows. And so we then can see that each of these places have a story associated with them. And so upstate, there's these green amendment tests happening at High Acres and Seneca Meadows. So our trash doesn't go away, it goes to a real place. Here's just one from the South Carolina news. The smell of the landfill is like money, or just sour garbage. It would take your breath. So like these are real people in real places that have these mountains of our garbage in their backyards. Here is somebody saved the EJ screen data set. And so this was sort of the end of me and Samantha's collaboration, at least when we got to the state of preparing for this presentation. We started to look at using EJ screen, look at the areas around the landfills and the transfer stations to try to get a sense of what's going on there with the different variables that's tracked on EJ screen. And so the next steps for this work have to do with making the maps more interactive, digging in more into these stories, the past, the present, and the future of these landfills and transfer stations, making these data sets and tools, giving them utility for achieving the statewide landfill reduction goals that so far we're not that successful at. Different partnerships for doing this kind of work and doing this study of social and health cost of landfills. Thank you.
Thank you. All right. So for the last third of the presentation, Dee, Jane, Shen, and Andrew will be taking over. Oh yeah, this is really sensitive. Can you just go one? Okay. This is us. Shen and Andrew are some really awesome data scientists who I've had the pleasure of working with, and I'm just here as the waste expert. Who's working a lot with garbage. Let's go. So yeah, as Samantha and Matthew said, there's these 5 data sets. They're separate items on the New York City Open Data website. The goal of the dashboarding team was to merge the 5 data sets together and create a free, publicly accessible, very low cost to maintain dashboard in which anybody who can read a map or a table could go into and like actually get the important information out of it instead of spending hours sitting at a computer trying to figure out what the heck these tables mean. So we'll give a demo of the dashboard and then we'll show you the steps we took to actually put that together so that if you want to make something similar for another open data data set, you can have at it. Yes, please. And just again, for terminology, we'll talk about community districts a lot. This is like where the waste comes from, as Samantha said. We'll talk about disposal facilities. So in the data sets, these are transfer stations and some waste energy facilities. And then disposal sites, which is where they end up going after the transfer station. And again, this will include landfills and some waste energy plants. And it's not including any recycling nor organics. This is all just black bag garbage. All right. I'll pass it off to Andrew to give us the live demo of the dashboard, which can currently be accessed.
Awesome. Thanks, Shane. Hey, everyone. I'm Andrew. So I'll talk you through our Where Does New York City Garbage Go? The question you've all come here to answer. So I'll be talking through our first 2 pages for the most part. The first of which is high-level annualized metrics, just to give us a sense of the key types of numbers that we're interested in the New York City residential waste space. So specifically, we have a filter here for the year of 2023, but you can go through each year all the way back to 2018, which is the first year that Samantha had helped us get our open data for. But specifically for 2023, there are 3 key metrics that we want to focus on, and they're weight, cost, and distance. So weight is the total tonnage of residential waste that's disposed of within New York City residences, and that's a whopping 2.5 million tons of waste. To kind of put that into perspective of like what these giant numbers actually mean, it's basically like hauling 500,000 number of elephants out of the city, which is like an insane number of elephants. The second metric is cost. So obviously it's not free. We're using taxpayer dollars to do this service for us. So the total cost associated with disposal is over $400 million. And then lastly, as Samantha and Matthew had alluded, it's not being dumped in New York City backyards. They're actually traveling on average over 412 miles away from our city streets. So some of the other numbers that we have on this chart are talking about like historical comparisons because we have year-by-year data. And as you can see with respect to the cost to dispose, it's actually gone up nearly 30% since 2018. And you can see in this year-over-year chart, the cost to dispose line graph in red has steadily ticked upwards, whereas the tonnage of refuse has actually been a little bit more inconsistent. So definitely some deeper patterns to dig into there and understand the underlying drivers of cost. The last chart that I wanted to touch on this page is actually something that Matthew and Samantha had also alluded to. It's just the percentage share of waste based on the disposal site types, right? We had the 2 types, landfills, as well as the waste to energy incinerators. And just re-echoing the point that Matthew said, where about 2/3 of the waste actually ends up in landfills and only about 1/3 ends up in the combustion places. Next. Awesome. So now this is our second page, and just a preface, there's definitely a lot of information on this one. So I'm going to try and take it a little bit slower. But this is going a little bit deeper into kind of like the interactive maps, as well as some district level granularity, so you can understand exactly where does your personal waste end up. So just to reground us, we're still looking at the 3 key stats, right? We're looking at weight, cost, and distance. And as we engage with the borough filters and community district filters, all these numbers and maps will change over time. But first, we're just going to talk about the maps. So the one on our left here is a bubble map that talks about the key points of interest, right? Our community districts, which are the yellow dots, small yellow dots. The facilities where the waste is picked up and their transfer stations are these more slightly deeper orange. And then the really, really deep orange is the disposal sites that it ends up. Shen, if you want to just zoom out a little bit beyond it. Yeah, so as we zoom out, you'll see that all the other disposal sites will start to show up on the screen. And the last point I wanted to make about the bubble charts is you'll notice that certain circles are bigger than others. And the size of the circle is proportional to the tonnage associated with this point of interest. So as it's getting pulled out of New York, it's ending up in these disposal sites, the largest of which, Shen, can you focus on the big circle? Thank you. So that's, and hover over it. So you'll see the majority of our waste ends up in Virginia, really, really far away at a site called Amelia Maplewood, where specifically over 700 tons of waste end up really, really far away from our city. So with that, I want to transition to our routes, which are possible thanks to the ones that MacBride provided us. So you'll see 2 different colors, and we'll zoom in a minute. The first of which are the long haul turquoise routes that are representing the transfer stations sending trash all the way to the disposal sites. And that's why it goes from New York all the way to like Niagara Falls near Canada, as well as far down to South Carolina. But Shen, if you zoom into the lavender section, these are representing the intra-city routes that are bringing the trash from your curbside to those transfer stations. So Shen, if you can just filter to Brooklyn just to give us reduce some cognitive overload. You can just like only, yeah. So if we just filter to Brooklyn and look at the network, we're basically going to be able to see and sorry, Shen, also for the bubble map, can you zoom out to see where the facilities are? Awesome. So we can use these 2 maps in conjunction and see, hey, for all of Brooklyn, we're sending trash to 3 disposal sites, the largest of which is still in Virginia. And the routes that it takes to get there start at the city level, right? If we're looking specifically at Brooklyn, depending on which neighborhood you're in, your trash will be consolidated at a specific facility that may then take a ship to cross into New Jersey. And then, Shen, if you zoom out, thank you. We'll hop on a rail and then go up north or south, depending on its final destination. So that's kind of the flow specifically for New York City. And then I just wanted to show you specifically what it might look like for an example borough, an example community district, if you were to apply this for your own neighborhood. So personally, I grew up in Ridgewood. So Shen, if you can filter to Queen 7. And if you don't know, you can, if you don't already know your own community district, you can definitely just click that link and figure out which community district is most relevant. So yeah, if you can zoom in, Shen, back to the route map. Yeah, so sorry, I'm District 5, just remembered. Oh, that's not rude. Awesome, that was more people like us. Awesome, so that is Ridgewood, and it gets sent to Waste Management Review, which is on the western side of Queens. And as you'll see, it hops on a giant rail. So Shen, if you zoom out, and it does this giant northern trip that has to go all the way up to nearly Albany before it comes back down to make it down here. And it's simply just due to like rail infrastructure, right? So definitely potentially some room for improvement in terms of where we're sending our waste. But I'm sure being smarter than me, understand the reason why we do stuff like that. So that's it for this section. But Shen, can you just retoggle all the data again? So undo the filters with the minus box. So those are the interactive map components, but we definitely have some additional charts that we want to go through on the next section below. So if you're like me, you want to know, how does my district compare to any of the other districts, right? Like I want to know more than just where I live. And that's why we have this chart that has the rankings based on the 3 key metrics that we're interested in, right? Weight, cost, and distance. And the rankings indicate if you have 1, that means your highest number for this metric of interest. So there's some pretty interesting insights that you can glean from a ranking dashboard like this. And I'll just focus on two examples, one of which is quite intuitive. So if we look at the first row, Queens District 12, it generates the most refuse out of all the districts, about 80,000 tons. And correspondingly, it also costs the most to dispose of those tons, right? Like the facilities are charging based on the tonnage, so that makes sense. So that's one of the intuitive examples. But one of the more interesting ones that suggests there might be something that we're missing is row number 9, Manhattan 12. Sorry if the text is a little small. Manhattan District 12, where the 15th ranked district in terms of the amount of tonnage that they produce, and simultaneously ranked 54 out of 59, which means in terms of distance traveled. So they have one of the shortest commuting distances, but somehow they over-index on costs, being ranked 9. Right? So they're not producing as much tonnage, but it's costing a lot of money. And that makes us a natural question is to ask, why is that? And that suggests that there must be some sort of variable that we're missing in the picture. And that's what we kind of like did regression analysis. It's still work in progress, but we don't have to go to it. It's there if you want to reference. But we looked at some of the other factors that are going into what's affecting the cost to dispose of this waste. And it turns out one of the key factors is actually the type of disposal site, right? So a lot of the Manhattan districts will send their trash to the waste energy incinerators, and those are more expensive compared to traditional landfills. So there are definitely things happening behind the scenes that affect the costs, the taxpayer costs to dispose of our waste. So those are some of the insights that we can glean from ranking dashboard. And then Shen, scroll down to the last section of our drill down charts. So we've talked a lot about like individual districts, but sometimes we want to aggregate at the borough level, right? And that's what these charts let us do. And again, we're still looking at the exact same 3 metrics: weight, cost, and distance. And what we can see is, for example, if we focus on the tonnage is actually very proportional to the population size within each borough, right? Queens and Brooklyn generally have the most. Manhattan and Bronx have about approximately half, and Staten Island, I think, is a third or a fourth of these 2 boroughs. So at a high level, we generally see that the tonnage is very proportional to the population basis. But the neat thing about the drill down charts is we can actually go a level deeper. So Shen, if you can right click and then click drill down, just on the chart, and you run the chart, this is fine. Our data will then break down and look at each individual district in a visual manner. And if you just hover over them, you can see like exactly which district we're talking about and the corresponding tonnage. So this way you get another visual way to represent how each district stacks against the other ones. So with that, we'll conclude the demo portion, but I'll hand it back to Shen to talk a little bit more about the data background.
Hi, my name is Shen. I'm just going to talk very conceptually about the steps it takes to process these data sets and prepare them for dashboarding. So we're going to start with acquiring those data sets. So we work primarily with data set from like number 2 to number 6. These 5 data sets are the tonnage and waste trajectory data set that Samantha and like Andrew and Jane has like Matthew discussed. And they tell us how much waste is generated, how much waste is transported, where are the waste generated, and where are the waste transported from and transported to. We brought in one additional piece of data set number 1, New York City community districts. It's like a geography, it's like a boundary. It's there to really aid the geoprocessing step, which I will explain later. Next slide. Yeah, so next set, data set merge. Here, we want to create one master data set that will contain all the information in the 6 pieces of data set that we just showed you. And using the top 4 data sets, we are able to identify the flow of waste from generators to facility, from facility to disposal site. And using the last 2 data sets, we created the trip or the route from community district, from like generators to facility to sites. And the second part of this trip from facility to disposal sites are we rely heavily on the data that Matthew provided. And eventually in the merge data set, we are able to match the waste flow and the route geometry using mutual origin and destination So in each row in a data set will has a start, has an end, has the tonnage of waste, the flow from start to end, and the trip to connect the start to the end. Next it. Data processing workflow. We process the waste flow primarily in Python, and the root data primarily in ArcGIS. And then we used Python to create this merged dataset master file before it is exported and migrated to the Google platform. Next one.
I'll just jump in here for a brief minute. It was definitely key to make sure we're doing the data cleaning process. So for reference, if you guys are interested in trying to replicate our work or dig deeper, it is really important that you make sure you do this. We've included this just for comprehensiveness, but we won't actually be talking about the details within the original presentation. Definitely can feel free to follow up or ask some questions during the Q&A. But I'll give it back to Shen.
Yeah, the geoprocessing part. So for visualization, we created two kind of trips. One trip is the trip from generator to facility, and the second trip is from facility to disposal sites. For part one, we kind of approximated this household generator to facility trip, assuming that all kinds of this trip will start at the center of the community district. It is not it's represent what a typical trip would look like, not necessarily like an actual real trip from a household would look like. And for the second part, this trip from facilities to the sites, we work with Matthew to repurpose and reformat these routes, and we add in this one piece of information, which is the distance of these routes.
Thanks. Hi, so I'll be talking a little bit more details about the dashboard design. So the first question that we had to tackle was, which platform do you want to select? And if you're anything like me, you make most of your major life decisions based on two things: cost and convenience. So in terms of cost, we selected Looker because it was the cheapest option to post an interactive dashboard to the public, y'all, at hopefully less than $1 a month. We'll find out when the bill comes. And just familiarity. Like, our team was already quite familiar with Looker, so it's pretty easy to ramp on and build the dashboard relatively quickly. Next. So continuing on from, sorry, thank you. Continue off of where Shen left off. So we wanted to send all those juicy data sets into Looker. So the process we did to do that was have Python create a bunch of CSV files, right? Like Excel files, basically. Then we uploaded them to Cloud Tables in Google BigQuery. And from there, once it was in the Google ecosystem, it was really simple to just add them as data sources within Looker Studio. Next. But even though Looker had many pros, there are definitely some challenges that we kind of ran into. The first of which was Looker has a constraint where you're only allowed one map object. It's like a point or a line per Looker map. And that's the reason why we ended up having both a bubble map and a route map. Ideally, we would have wanted them overlaid onto a single, more usable from each chart. But because Looker doesn't like bubbles and lines together, we had to implement it like this. Next. So design challenge number 2 was about creating a more comprehensive visual network based on the default view. And that's because Looker has another constraint where they're capping the number of points that they'll display by default. That's just because it'll just overload the dashboard and it'll lead to performance issues. So we implemented some clever workarounds. There's a bunch of nitty gritty that I won't go into, but you can definitely follow up and ask, to go from the before, where we're only actually able to see one long haul route and none of the intracity routes, to be able to at least give a better, more accurate, holistic representation of what the routes look like, even before we zoom in or applying filters. Next. And then one of the last challenges that we faced was just juggling so many various granularities, as you saw from like Samantha and Shen. Like, we're working with a bunch of different data sets. And it was just really important to make sure that we're not over or under counting everything and making sure that all the granularities line up. Just because not every waste trajectory, as Samantha said, follows a clean ABC trajectory from district to transfer station to disposal site, right? And some of the edge cases that we had to account for with respect to tonnage, for example, where some facilities actually send trash to multiple disposal sites. So we have to make sure we're splitting that tonnage appropriately based on the underlying open data. Similarly, for the routes, there's actually some routes that are multimodal. as Matthew had alluded to, where they're first hopping on a ship to cross the water, and from there they move on to a rail that gets sent even further away. So marine transfer stations are particularly known for this. So as a result, we have to make sure we're segmenting the routes from the facility to the transfer station according to the correct modality of transport. So one such example was Queens District 7. Explains why it filtered to 7. Queens District 7 is a key example of that, where first, yes, they had the Lavender Intercity route that brings it from the community district to the transfer station, hops on the water, ends up in New Jersey, and from there we'll go north or south, depending on the actual final destination. So that concludes my section. I'll hand it back to Jane to close this out.
Yeah. So thank you, team. Ideas. We do have a few ideas for future work that we're working through, but obviously if any of y'all have ideas, feel free to pitch it. Like we said before, like right now we are missing a few like pieces of the puzzle. For example, we're estimating where the routes start in the community district, but we don't have, for example, data on the actual routes the DSNY trucks go as they're picking up from household to household. So that vehicle miles traveled is not included in any of this analysis. We'd love to put it in there if we could. We also don't have information right now in open data on the organics and recycling streams to this granularity in order to do a similar dashboarding exercises. So we would love to see that in the future as well. And then, yeah, like other things I'm sure people would be interested in is, how can we use this information to like try to target better recycling and organics participation, like normalizing the data per capita to see like which parts of the city could use the most improvement, more education, and that kind of thing. So yeah, that's it. If you would like to have a look at the dashboard, this code should be active. We also have an email. It's nycwastedashboard@gmail.com. If you reach out to us, we can also just send you the link there. But hopefully we're gonna land it somewhere. Working with Samantha right now to land it somewhere where we can like house the URL so that people can just link to it instead of just knowing us to get to it. Awesome. Thank you so much, everyone.
Sure. Awesome presentation, everyone. I mean, I feel like you just from how packed the room is, you can tell how interesting this topic is, and you all did a great job presenting it. My question is how this partnership came about. You made the story of how the data moved really clear, but how did you all come to collaborate together and just also decide to do this event at your city school data?
Well, I met Matthew on LinkedIn, and I don't even really remember how. And I met Jane when she was working on commercial waste characterization study with sanitation that I was involved in. And
Yeah, and
yes,
so I used to be the project manager for commercial waste zones on the consultant side. Shen was on that team as our, head data scientist for a few years. And Andrew is Christina's boyfriend who set the room back there. And Christina was also on that commercial waste team for a very long time. Part of this brother. Yeah. And he wanted something to do in his fun employment. So we're a bit of a hodgepodge, but you know what? That's really awesome. We all clearly love data. We all clearly love garbage and have to do this.
Yeah, just to add on to that, I was honestly really thankful to meet this group. Like everyone has been super helpful and friendly. And as a non-subject matter expert, it's been awesome that I can just learn from them and get this opportunity to dig into data thanks to their support.
From the coordinate. Yeah.
Great, thanks. So two things. One, potential interesting like future ins to this. I was thinking about how you said that, and what does the district call them? Manhattan is like the most expensive, but it's actually because they put their stuff into waste to energy, which is, hopefully, fingers crossed, we hope that this is a more sustainable way to deal with our trash than sending it to landfills out of state. And it would be kind of interesting when you look at the full journey to like break it down in terms of CO2, like if you actually have to go all the way up to Rochester just to go all the way to Virginia, that's probably adds a lot of like emissions and other inefficiencies, obviously, to the process. Whereas like just quickly shipping it off to waste to energy, maybe it's more expensive, but maybe actually is more beneficial overall. That would be kind of interesting to know. And then the second is just a question. I saw on your data, like considerations that like the Bethlehem and one other site had the same ID number.
Yes.
What was your kind of reflexive process for, like, were you able to then go into the data set and then update that so that the open data is better? Or did you have a process for that? Definitely curious.
Yeah, thank you so much for sharing that. So first, just want to say thank you. I definitely echo your very good and interesting suggestion. I wish we had the granularity of data to access that. As you guys know, like open data generally sends quite aggregated information. So it's a little bit hard to validate that. And that's what even our like linear regression analysis is quite rudimentary. We don't have a lot of data points to go beyond exactly what is associated with this facility. Like we definitely don't have like carbon emissions or information like that, for example.
Can I just ask a couple of things to that? Number one, I've done carbon analyses for sanitation, and transportation does not count or matter as much at all as you would think, right? It's very small part of it, which isn't that it shouldn't be done, but that's true. Also, we have been rushing to get ready for this. And so, especially if you're a member of the press, any kind of fact or figure so far, this is draft, right? We're focusing on the data and the tool. We need to do a final triple check of all the data, right?
Yeah, if you see any errors, please email us.
Right. So please, the cost information is very interesting. But I need to go through everything. This is actually the first time I've seen their metamastic work, right?
And it's the Selkirk crossing at Albany, now Rochester.
Sorry, I didn't answer her question. Amazing eye that you were able to read that so quickly. So unfortunately, I didn't reach out to Open Data to work with them to clarify. I think that's a great suggestion. In terms of kind of like how I found or approached it, I basically was like, I don't know anything about this data in any kind of context, like not beyond data, beyond being a data analyst. I also like didn't understand the data itself, right, in the waste space. So I just took like a really critical eye and was like, assume nothing is given. And I was looking for dupes anywhere. And as a result, that's how I found this. And I QA'd against our waste experts and I consulted them and they were like, yeah, that looks wrong. That doesn't look right. And then I would had the subject matter experts give me the best course of action on how to actually rectify any anomalies in the data.
We'll go to the friend of this table. Just you made a comment about trying to get the local collection route data for each sanitation district. I led a team 15 years ago. We were paid by DSNY. We digitized that for Staten Island and we did it down to the address level, every address. And we gave them the existing routes and then optimized and balanced routes. Let's say if you switch to the optimized and balanced, you're going to save X, and X was big. And then we delivered that, and there was an argument between management and the union, and we were told don't do any further work, and never went beyond that. And I think you're going to struggle to get that collection route data. Very
I
specific.
don't think we're going to try. I don't. It's not worth it. It's absolutely not worth it. I would also point out that the modeling that takes it, this from the center of a community district, really it's the garage that's the start point to go to the transfer station. So these are approximations, but I do not see a value add of trying to fight for route data, road data from sanitation. Also, I will say it's constantly changing, it's constantly updated. So I don't have any plans to integrate that. And frankly, from a greenhouse gas emissions standpoint, folks, maybe not local pollution, that's a different matter. But greenhouse gas, it's not a big part of the overall picture of the burden of waste. You'd be surprised.
I'd sooner want to get the recycling organics, like this information on open data. Sorry.
You had a question in the back? I'm in the back. Sorry. Our Fred, my back.
It's a very broad question because we saw a lot of like comparing of boroughs and community districts, but like how does this as a city or region compare to others? Like, is this just pretty much what it looks like for a large city to do this sort of same thing, or is New York different because we have like all these waterways and other cities might not? Like, how does this all like compare to anybody else doing this sort of thing, which everybody does.
Okay.
Very broad.
In the Northeast, right? It's a very densely developed part of the country. There's going to be a lot of waste export, right? If you're going to other parts of the country, like Phoenix, Arizona, where they have nothing but land, right? It's going to be going a much shorter distance. It's also the size of the city. Many cities are not going to have multiple export contracts. Some places still have their own landfills that they use. Overall, interstate transit or transport of waste is an economic activity that's been going on for a very long time. That's protected under interstate commerce. So, New York City is a mega city and it is surrounded by water. So that's part of the story, but it isn't exactly unique in doing this.
Yeah, I would agree with that. It's not exactly unique, and like pretty much every town or city you see out there is going to do everything in a slightly different way, having consulted with a lot of other places. Some people do it private, some people do it public, some people it's a scramble, and it's basically whatever they figured out decades ago and have inherited since then.
Did we go to?
Yeah, I had a question about Virginia. You're taking the garbage all the way down to Virginia. That's a Commonwealth state. Is there a contract with New York? Are they getting like a tax break? Why are they allowing New York City garbage to be in this state?
Every community that hosts a landfill or an incinerator is required to sign a host community grant in order for sanitation to contract with it. I am not up to date on the state relations between the state of Virginia and New York City. That would be something to look into. On the other hand, to get a host community agreement, that's done through the local government, right? So the local government says, okay, we're okay with having a landfill here or an incinerator here, which does not necessarily reflect what the people want, right? Yeah, thank you.
Funding. Funding. Where you funded? Of course not, right? It's like a volunteering project so far.
Yeah, we're self-paying that $1 a month.
You have no funding. None.
Do you have plans? Who will be buying? Who will be funding? It's such a useful service actually for community.
We're figuring it out. But no, we do not want to be beholden to anyone that would that would affect this. So we don't necessarily want corporate funding. We don't necessarily want city funding. So we're thinking about it. But the funder needs to be more of a funder that's interested in good governance, because that is what this is all about.
See one in the middle. You said that vehicle miles traveled is not a major factor in greenhouse gas emissions from waste. So what are the major factors?
Landfill emissions. And, to a certain degree, waste energy or combustor emissions.
So,
Stationary emissions.
so the way to get it down is to reduce the amount
Yeah.
of waste going to landfill.
Yeah. I mean, the transport is important, but a lot of it's going by rail, number one, which is way less greenhouse gas intensive than truck. And even if it were going by truck, it would be a small part of the overall emissions. And organics go by truck too. So.
And I wanted to mention that these routes, I did my best, right? So we don't have information about the specific routes, but I did trace these from real highways and real rail.
I made Matthew do that. I'm like, as the crow fly, let's figure out what are commercial long haul routes.
Yeah, they get it started in, and then you
Yeah.
just have to poke.
Yeah.
So thank you, Matthew, for poking.
Right.
I can be out there for one more questions. I already gave the nod back there, so that's my promise.
It's a softball one. This is my first talk on garbage. How does New York City do? Are we doing a good job or compared to like our neighbors, or are we doing a horrible job?
Okay, this is what I tell my students. We are we are not terrible, despite what you may have heard, and we're not wonderful, despite what you may have heard. We are okay. We're we could do a lot better, but we're not in the gutter.
We have less than a minute, but that
I-
you feel good about that unless we have a quick one.
Yeah, super quick. Just confirming. So none of our waste is transported internationally.
Oh, no. Well, recycled material.
Yes, get exported, but trash, absolutely.
And that's kind of, thanks for the quick one.
Good job.